uploaded in the drive, and any other study material I will upload that one also. Okay, so let me start the recording first. So sometime I might forget to record the session, so Kalyan or Sitaram Laya, you remind me of that. Okay.
Yes, sir, we will.
Yeah, it just started. Yeah. So so in previous class, I gave you a brief introduction about the course, how we will evaluate, then a brief intro to the mechatronic system, it, its advantages and scope of mechatronics, and also I gave you a brief example of some high-end mechatronic system which are currently used by various agencies. Okay, so today we will look into the element of mechatronic systems and mechatronic system design. So mechatronic system and mechatronic system design. Okay, so we will cover this, and we'll try to cover one example of a mechatronic system. And currently we will be covering a washing machine, automatic washing machine. Okay, so starting with uh, the elements of mechatronic system. So as I previously told you that mechatronics itself is an interdisciplinary stream which combines the knowledge of mechanical, electrical, electronics, and computer system. So it majorly plays, or it majorly intersect between three domains, major domains. Okay, so you have electrical and electronics, you have mechanical domain, and this is your,
Hello,
yes.
sir. You haven't shared your screen, sir.
Oh, sorry. Yeah, yeah. Sorry for that. Today we will discuss these elements of mechatronic system and mechatronic system design. And after covering the basic aspect of mechatronic system design, we will cover one simple example of automatic washing machine. So in previous class, I told you that a mechatronic system or mechatronics is the interdisciplinary stream which lies between a domain of mechanical, electrical, electronics, and information technology, or you can say computer science. So information tech. So your mechatronics lies somewhere here at the intersection. So so if you consider uh, a mechatronics, so it consists of mechanical, and in mechanical system you generally deals with pneumatic, hydraulic, thermal system. Then you have electrical systems like relay, solenoids, motors. In electronics, you deals with control systems. Okay, and finally in information tech, information technology, you have basically computer architectures. Okay, you have AI and ML, or some system theories. Okay, but see, don't worry. You there is no need to study all these things. You might be wondering that what if we have to study in this subject? We will cover a very basic aspect. and also some derivations are also involved, some block diagrams are also involved, which are very simple at the beginner level. So this subject is not that much that tough. It will give you a brief intro to mechatronics, and it will make your foundation. Okay, so don't worry about after seeing this term, don't worry. And I think few of you might know about this AIML and all this thing, but there is no need to worry that whether we need to study this. We have designed the subject as per the mechanical engineer point of view. Okay, so coming to a mechatronic system, a simplest mechatronic system or a device is your servo motor. So servo motor basically takes a sensory feedback. It adjusts the motor in terms of speed in order to uh, get a precise control of positioning. Okay, so basically a servo motor basically takes a input in terms of electrical signal, then it will be having some control and feedback system with which this this will receive a sensory feedback, and it will adjust its speed to control a precise motor. So a typical example, the servo motor are used in robotic arms, CNC machines. Okay, so let me give you. So so a servo motor basically consists of how it comes under a simple mechatronic system. It has a mechanical components, okay, which includes your rotor, stator. Okay, this we will brush it up in electrical system. Okay, then in electrical system, we generally in servo motor we generally deals with uh, sorry, field wiring. Okay, we generally deals with rotor windings. Okay, then in electronics we generally have sensors, encoder, or PLC system which control the logic. Okay. Apart from that, the other mechatronic system examples are uh, your digital camera, washing machine. This we will cover. Then you have anti-lock braking system, that is ABS. Then we have microwave heaters or microwave cooking equipments. Okay, so this comes under mechatronic system. Apart from that, there are advanced mechatronic systems like robots, humanoids. Okay, but these are very advanced version. So let me give you a brief overview that uh, so this is a system that we have developed for welding and AM purpose. So if you see here, we have this block, and one block is here. Due to this color background, you are not able to see it. So these are two servo motor, and apart from that, we have positioning system, and this is a human machine interface which is controlled by a PLC system. Okay, so I will give you, or I will explain you this setup in more detail. So this setup we have developed for automatic welding. During your workshop lab, you might have gone through this. You don't have a automatic welding system here, but we during lockdown we are able to develop this. So it's a servo control, so it's a kind of mechatronic system which can provide you welding in X and Y direction. So this was developed by funding received from DRDO. So the typical how this system work or PLC logic controls we will cover at the end when we are covering the PLC system. Okay, so here you can see this servo. The role of servo motor is to, from this human interface, we'll adjust the speed and position. So according to that, the feedback system will provide this detail to your servo motors, and on the basis of that, this servo motor rotate. and it will position the welding torch to the necessary position, and it will travel with that particular speed. Okay, so this is a system. Now comes the mechatronics system design. So in order to design a mechatronic system, we have to consider some key elements. First one is your information system. Second is your mechanical system. Okay. Third is your electrical system oblique or electronic system. Okay. And finally, you have uh, a computer system. Okay, so this four component as a whole makes a typical or design a typical mechatronic system. So any mechatronic system should have this four or five. In some cases, electrical and electronic system are kept separately. So this four and five system are the typical component of a mechatronic system. Okay, although this four and five components are having sub components which are added or which are included in the mechatronic system as per the design need, that what particularly we want. So accordingly, these systems are the subcomponents are developed or decided. Okay, so first we will cover all this component one by one. So first is our information system. Okay, so information system basically deals with the information we want to information in terms of what is the need to develop that system, what are the inputs, outputs expected from the system. So in order to accumulate or in order to process this all in information, we generally take help of modeling, simulation, control, and optimization. And after following this four step or after processing this necessary information, we develop the prototype, and finally we deploy the product. Okay, so if you consider this modeling and simulation first, so so modeling, basically you have, sorry, modeling and simulation, so it has two component, one is modeling and simulation. So uh, if you consider a model, so model will be a physical representation of your real-time system. Okay, so so in order to develop a model, you consider a physical representation in terms of physics-based equations, force equations, and you develop a representation of a real-time system. But you should keep in mind that your model should be close enough to the reality, but it should not be complex. So it should be close to reality, but be a it should be a simple model in order to make it more understandable, or it should have more clarity, so that basically we have to consider the understanding of that model. So you make it close to the reality, but it should not be complex, you should keep it simple. Okay, then you have simulation. Okay, so in simulation we basically simulate the model, and we study the behavior and performance of the actual or a theoretical model. Okay, so in information system, basically the first necessary step is need identification. We have to identify the need. So uh, your uh, need if you talk about, these are technology based, society based. Okay, we have different types of needs, but in terms of mechatronics we are generally dealing with the development of technology, so we will take care of technology based needs. So first we have to identify that why we need to develop the particular product. And in terms of, in mechatronic system, your need is basically driven by competitiveness in market and customer demand. So these are the two basic fundamental which drive the designing of mechatronic system. Then you have to design a concept, so we have a concept design, then modeling. Okay, and finally control. So we have to we should have a control system through which we can minimize the error by taking a feedback between input and output signals. Okay, then finally we have optimization. So basically in optimization, uh, you might be having in previous semester, I think you have this optimization subject, I think as a elective, I am not sure. So basically in optimization, you take help of various mathematical equation or various statistical tool through which you optimize your process in order to get a good output. And finally you go for prototyping. So in prototyping, basically you develop a scaled down version of your model. Okay, and you test that prototype in simulated or lab conditions. Okay, and after that, after successful prototyping, you finally deploy your deployment of the product is there. So see, in this prototyping, a typical example of prototyping is if you see your uh, self-driving car. So in order to develop this self-driving car, first prototyping is done in terms of deep learning based study, where you develop a model so that your car can distinguish between footpaths, traffic lights, humans. Okay, and also after training this model or after developing this model, you deploy this model in a system which is basically mechanical plus electronic system. So you develop a scaled down version of a car. Okay, basically a small car will be developed, a tabletop car, and these codes are fed to this uh, prototype, and we need to check the uh, accuracy of our model. So before developing or before directly deploying the product, you have to test on prototype. You cannot launch directly into the market. Okay, next component is your, that is your mechanical system. Okay, so basically a mechanical system concerned with a system which is under the action of, concerned with a system which is under the action of force or moment. Okay, so if you consider your mech system or mechanical system, uh, it has it has three components. One is your actuator, one is your control, and another is your sensor. So in terms of actuator, basically the function of actuator is to convert energy or signal into motion. So if you are dealing with a mechanical actuator, we have a pneumatic actuator. Okay, you have hydraulic actuator, and you have thermal actuators. Okay, similarly if you talk about control system, so in order to control the speed, uh, in order to control the force, in order to decrease or increase the force and speed, you need a control system. So in mechanical, the control systems are in terms of control valves, it is in terms of gears to speed down or speed to increase the speed. Then you have piston cylinder assembly. Okay, and in terms of sensor, in order to measure force, you deal with gauges, that is your strain gauge. In order to measure temperature, in case of a thermal actuator based system, you need thermocouples. Okay, and in order to test the pressure, you need pressure gauges. So basically, a mechanical system will be having three components: actuator, which will convert energy into motion. Okay, uh, then you have a control system which will help you to control the force or moment or speed. So you have control valves, gears, and cylinder. Then you have sensor. In sensor, you have strain gauges to measure the forces, thermocouples, and pressure gauges. So, so in case of a mechanical system typically follows uh, Newton Newton's law, three laws, and gravitational law, then parallelogram law, sorry, parallelogram law, and third, it follows principle of transmissibility. Okay, so these uh, three things a mechanical system uh, should follow. Then the third system is your electrical and electronic system. Okay, so this system basically deals with Q, that is charge, I current, V voltage. Okay, so these system basically deals with Q, I, and V, that is charge, current, and voltage. Okay, so if you talk about electrical system in mechatronics, you have two type of system. One is your communication system, which are used for information transfer, in terms of information transfer, in terms of transmitting the signal. So you have a low electrical signal which is transferred into high electrical signal so that it can be measured. Okay, then you have power transmission. So this system generally used to transmit power. So you have servo motors. Okay, for this particular purpose. And if you talk about electronic system, so electronic system basically used for the signal conversion, basically analog to digital and digital to analog. So uh, uh, a DAC system, or we will cover in this digital to analog control system, we will cover in future classes. Okay, so but right now you understand the electronic systems are used for signal processing. So signal processing basically to convert analog to digital or digital to analog uh, signals. So if you talk about electrical system, so they have two components. One is input signal conditioning. So you have to condition your signal. So conditioning means generally sometimes you have a signal in terms of very low current or low voltage. So a signal conditioning is done in such a way that you can enhance that low incoming signal, and you can enhance that so that it can be measured. Okay, so it can be enhanced using filters. Okay, so if you consider a filter, so a filter is typically used in audio system. If you talk about, so you have some background noises. Okay, we will cover this. Okay, don't worry about this. So this is your input signal and you have background noises. So in order to have a clear input signal, you have to remove this background noises. So you generally provide filters. So this filters will remove this background noises or minimize the background noises so that you can typically able to understand this incoming input signal. Then you have amplifiers. So basically amplify the input signal. Okay, so when it crosses the amplifier, it will be magnified. Okay, then you have circuits. Okay, so circuits are basically used to transmit the signal. Okay, next is your control. So a control system basically used to minimize the error between input and output. So it can be controlling can be achieved using logic circuit, using PLC, that is programmable logic control, and also using sequencing. Okay, So how this sequencing control is achieved, we will cover in few minutes. Okay. So, and the last component is your computer system. So a computer system basically used for programming, controlling, and iterating the uh, systems. Okay, so programming can be used with the help of various softwares like LabVIEW. You have Simulink, you have embedded C. Okay, but nowadays other languages or soft platforms are used, like MATLAB is there. People are using Python, being a open source system, so people are using Python because you will generally get a good results. Sorry, a good coding, and this community is very big, so you can get your solution easily in Python. Okay, so these are the typical computer system. So this covers your mechatronic system design. So every time during the design process we are talking about control or control system. So a control system basically control input and output signal in order to minimize the error, and in order to minimize the time response. Okay, so basically you understand like this. A simple example of is your water level indicator. Okay, so you have inlet here, so you are feeding this tanker with a fluid, and you have a water level indicator here. Okay, so once you switch on the input, so water will come and it will be filled inside this system. Okay, so the input is in terms of your motor on. Okay, okay, so once you are feeding it, so this is a water level indicator, you provide a sensor here. So the work of a sensor or control system, so that it will immediately detect this level, and it will immediately transfer the signal to motor so that it can be switched off. So this time of response should be quick. If you are having a delay or lag in this time of response, so your purpose won't be solved, and it will be a failed system. Okay, so this is the main highlighting role of a control system, that is to minimize the error between input and output signal, and to minimize the time of response. So coming to a mechatronic system, we will be discussing a typical mechatronic system which you all are using, that is a washing machine. So washing machine basically a sequential or event based mechatronic system. Basically, sequential or event based mechatronic system is it will complete one sequence, then only it will switch to the another sequence. Okay, so the operation or the desired output is reached in step by step manner by performing certain sequences. So if you consider your washing machine, you have a pre-wash cycle. Okay, where you will feed the cloth in the washing machine drum. So the washing machine drum will sense the cloths. Okay, after that, after sensing, the drum will rotate in order to measure the weight. Okay, if you see, your washing machine comes with different weight category: 9 kg, 6.5 kg, 6 kg. So it will sense the weight of the cloth. Okay, and it will rotate for a while, and then it will stop. Once it will be stopped, okay, so your machine will be ready for the wash. Okay, so then comes your washing cycle. So in washing cycle, this cloth will be washed with either hot water or a cold water. So you have machines, washing machine with both the provision, uh, depending upon the customer, that whether they are using a machine with hot water system or a cold water system. Okay, so once this washing cycle start, so it will also start rotating the drum. So drum will not rotate continuously in washing cycle. So it will first go like this in one direction, then after completing this, in this direction. then this direction, then this direction, which they typically show by animated images of the cloth, that with aerial something this is happening and it will clean your cloth in uh, a better way. But that is a typical cycle or typical dancing pattern of your drum during washing cycle. Okay, then you have a rinse cycle. So in rinse cycle, it will rinse the water from the drum. Then after completion of rinse, you finally have a spinning cycle, which is generally used for drying the cloth. So the cycle generally happening within these two blocks until your washing cycle completes. So initially, if you consider a manual machine, they have a knob with timings. I don't think you might have seen that one. So this have timing, and based on the experience and number of cloth, you will set the timer, and this timer will come back to its zero position. Okay, but now the washing machine are coming with microprocessor control. So they generally have pre-feed program like P4, P5, P3, or depending upon the name. Okay, so you select the program, automatically everything will follow this sequence. But whatever the machine you are using, you the cycle will happen after completion of one. So the event will be happening one by one. Okay, after assuring that one event is completed. Okay, so if you consider your cycle, so it itself has a different processes happening. First, in pre-wash cycle, it will measure the cloth. So you put the cloth inside, it will rotate for a while, it will measure the weight. Once that is assured, your inlet valve will open and water will be coming inside the drum. Then after that, once the water level indicator senses the amount of water is necessary, so this inlet valve is closed. Okay, the inlet valve is closed. Okay, and the machine, the uh, inlet valve closing happens once the water reaches a uh, requisite level. Okay, then you have washing cycle. So in washing cycle, based on the program you have selected, it will either change use the water in the same temperature, or it will heat the water. If it is having a water heater, so based on the temperature you have selected, it will heat the water, and the thermocouple will sense the temperature, and it will give a feedback to the heater, and your heater will be off. Okay, then after this heater off, your wash cycle start with the rotation of the drum. So the rotation of drum is in form, it's a patterned rotation. So based on the controller provided in the drum, uh, they will sense the rotation. Once the rotation in a particular direction completes to a particular point, let's say B, it will immediately send the signal. The control system will send the signal to the motor of the drum, and the motor of the drum changes the direction of rotation. Then it will again come to B to A. Okay, so likewise your washing cycle will complete. Then you have rinse cycle. So in rinse cycle, when the controller senses that washing cycle complete, it will open the outlet valve, and your water will be rinsed. Okay, so in rinse cycle, once the water is rinsed, again it will come back to your pre-wash, where apart from measuring weight, it will open inlet for water intake. So again this inlet will be open and water will be filled, and the sensor will sense the water level, and again it will signal, and again you will have this washing cycle. So this cycle repeats again and again until your washing completes, and once the washing completes, it will switch to spinning cycle. So in a spinning cycle, rather than a patterned rotation, it will continuously rotate in order to dry the clothes. Okay. So if you see the typical diagram of a washing machine mechatronic system, so it has a AD, means analog to digital converter. So this is the main processing unit. Okay. It has a CPU in which the programs are fed. It has a microcontroller. Once the program is, sorry, microprocessor, once program is selected, this microprocessor will come into action. Then you have actuators. Okay, so actuator can be electrical actuator, mechanical actuators in terms of motor. Then you have a sensor. Okay, so sensor will be water level indicators. You have door opening sensor. Sometimes people open the door, so immediately the door will shut down. Okay, you have a load sensor. Okay, then apart from that, other sensor will be there if it is a hot and cold type, so you have a thermal sensor also. Then you have keyboard there. So in keyboard you can select the program P1, P2. Okay, so program can be selected. You have a display unit. Okay, and you have this, sorry, this should have come inside display unit. And you have also few actuators here, so which will control, sorry, a control system will be there which will control valve opening and valve opening, then blower switch on. So like that you will have a control system. So this is a typical washing machine block diagram. So depending upon the type, you will find different type of a block diagram of washing machine in various resources available in internet. Okay, so this is the presentation I will upload there. So in presentation, a schematic of a mechanical system is there. So there is no need to fix to this particular schematic. You can made based on your own uh, decision. Okay, but if exam will be online, so all of you will make this type of schematic. Okay, then you have modeling elements. So you have modeling and simulation. So what I have told you that you should choose a good model. It should have a judicious trade-off between realism and simplicity. Okay, like the simulation. So this is a note. A model aims to be a true to the system, and simulation can be used to use a model to explore the state. Okay, then you have control system optimization, then mechanical system, electrical and electronic system, then computer system. Okay, and then this is also a, a life cycle of a product. So this is a typical window of a information system of mechatronic system. So coming to the feature that we have covered, that a modeling can be a block diagram. Okay, uh, uh, abstract model or a physical model. Likewise, you have simulation using numerical methods. Okay, it can be different type of mathematical or statistical based equations. Then you have designing. Okay, analysis, then real-time interfacing by developing a prototype, and the real-time interfacing can be done with the help of actuator and sensor. Then code generator, so coding can be developed in various languages that we have covered. Okay, and interface will be, which will transfer the codes to your mechatronic system. So this is a uh, this covers our first lecture or second lecture, but this is the main subject lecture. Okay, so if you have any doubt, you can ask. Stop the recording. Yeah, students, if you have any doubt, you can ask. Otherwise, we can end our session. I think few of you might have slept because you have continuous classes from 1:30.
No doubt, sir.
No doubts, sir.
Okay, okay.
No doubt.
Okay, so we can end our class here. Okay.
Yes, sir.
Yes, sir.
Yeah. So thank you all. Thank you for your patience. Okay.
Thank you, sir.
And take,
Thank you,
yeah,
sir.
Thank you,
yeah.
sir. Thank you, sir.
And also take care. Huh? Okay, bye.
Thank you, sir.
Nice.